Hello, welcome to this video. This is 8-2 and we're going to go ahead and talk about graphing exponential decay functions. In this video we will learn how to graph base 1/2 and base 1/10 exponential functions utilizing previous knowledge from lesson 8.1 about how to graph base 2 and base 10 functions. So let's go ahead and look at a prior knowledge question. Here we have two functions, g of x and f of x, and it says compare the transformations taking place on the function g of x equals 2 to the power of negative x compared to f of x equals 2 to the power of x. Well, for g of x, it has a c value that is equal to -1. C is equal to -1, and what ends up happening is we have horizontal reflection. Okay, now how does this tie into what we're talking about today? Well, if I have an exponential growth function, looks something like this. If I go ahead and reflect this horizontally or across the y-axis, I'm going to get a function that looks like this, which is an exponential decay function. Okay, so leading into what we're talking about. Just a reminder about exponential functions and its structure. An exponential function is a function of the form f of x equals a times b to the power of c times x minus h plus k, where our base has to be greater than 0 and the base cannot be equal to 1. Now, the domain of every exponential functions is all real numbers. You can plug in anything from negative infinity all the way to positive infinity. What we're going to include on the graphs of the exponential functions and identifying in the key features are the horizontal asymptotes. And the horizontal asymptote, this is just whatever your k value is. So y equals k, that is your horizontal asymptote. We'll also include key points, which we'll talk about, including y-intercepts and zeros if they are reasonable. And then lastly, end behavior. So what we're going to go ahead and look at today are exponential decay functions of the form that we just talked about. Now, one way to go ahead and write this is with a base value between 0 and 1. And this is what we'll first see. We have a base of 1/2. And then the second way is with a base value greater than 1. But our c value is negative. We're going to use a negative exponent property that will allow us to go ahead and graph with a horizontal reflection, okay? Similar to what I talked about in the prior knowledge. Now here are just some examples in analytic form of how we can write our exponential function, exponential decay function. So the first example is with a base value that is bigger than 1. You'll notice that we have a c value to the power of -1. And then that causes horizontal reflection. The second way, where our base is 1 over whatever that base is, okay? So this would be like base 1/2, okay? So we'll go ahead and look at the function f of x equals 1/2 to the power of x. Here is our first parent function that we're going to look at in this lesson, and this is base 1/2. Now, base 1/2, here's what I want you to notice. I want you to look at the following key points. If I plug in -3, 1/2 to the -3rd power, this gives me 2 to the power of 3. If I use the negative exponent property, I get 2 to the power of 3. And that is just 8. So -3, 8. If I plug in -2, we get 4. If I get -1, we get 2. If I plug in 0, 1/2 to the power of 0, we get 1. And then if I plug in 1, 1/2 to the power of 1 is 1/2. So I want you to think about these points, and I want you to think back to the last lesson, and I hope that you connect that these points are just a mirror or a reflection of our function 2 to the power of x. And so go ahead and look here. Here's our parent function, 1/2 to the power of x, or f of x is 2 to the power of -x. So again, these are base 2 functions. It's just with a horizontal reflection, okay? And you'll notice, instead of going right 3 and up 8, we go left 3 and then up 8. Instead of going right 2 and up 4, we go left 2 and up 4, okay? Now, the domain and range are similar to our parent function, 2 to the power of x, as well as the horizontal asymptote, but our end behavior changes here. Our function values, as x goes in the negative direction unbounded, the function values will get really, really large, and then they will decay as x increases in the positive direction. Now, when x increases towards positive infinity, these values are going to get closer and closer to the horizontal asymptote, and for our parent function, that would be 0. So enough about the overview. Let's go ahead and look again closely at this reflection and this idea. So here is 2 to the power of x. Again, notice these key points, right? -1 up a half, 0, 1, 1, 2, 2, 4, 3, 8. These mirror our points for exponential decay. I go left 3, up 8. I go left 2, up 4. I go left 1, up 2, and 0, 1. So our key point here, which kind of acts as our axis of reflection, is right here, this anchor point, 0, 1. That point does not change or is not affected by that C value with the mirroring. Okay, here is our first example. Please go ahead and write down g of x equals 1/2 to the power of x minus 2 minus 2. Now, the first thing I'm going to go ahead and do is I'm going to rewrite this as base 2. I want this to be base 2, and I'm just going to apply the negative exponent property. This is 2 to the power of -1 to the power of x minus 2 minus 2. And I'm just going to factor out that -1, or bring it up. So I have -1 times x minus 2 minus 2. So we have power to a power property, right? We multiply those powers. Okay, now from here, we can go ahead, we can identify a values, which are 1. We have a c value, which in this case is a -1. We have an h value, which is a positive 2. And lastly, a k value, which is -2. Okay, so again, the c value that is a -1, this is going to give us horizontal reflection. And then our k value being -2 means that our horizontal asymptote is at y is equal to -2. Okay, so I'm going to go ahead, I'm going to put down some axis here, and then I'm going to go ahead and graph this. So let's see, got to go down 2 for our asymptote. Okay, so we'll place our x-axis rather low right here. Our y-axis, we're going to the right 2. So maybe I'll put this more to the left. Here's our y, okay, and then our horizontal asymptote down 2. Okay, so I'm going to go ahead, I got my asymptote, and then I'm going to go ahead and graph my pseudo-origin. This is just h comma k. I'm going to build in my translations to everything I do when I graph my other points, and then I don't have to reflect and then go ahead and translate a whole bunch of points. I can just do the translation once. So my my pseudo-origin is at 2, -2. So right there, I'm going to graph everything from that location, and I'm going to go ahead and I'm going to plot my key points. So the key points, again, they're the same from the last lesson. So -1, 1/2, 0, 1, 1, 2, 2, 4, and if I have room, 3, 8. So we'll see. Okay. So I'm going to start from my pseudo-origin. My first one is -1, 1/2. So left 1, up a half. But I do have a c value. Again, this is horizontal reflection. So the c value, this multiplies with your x values. So I'm reflecting all of my x values. So -1 times 1. Instead of going left 1, I'm going to go right 1. Okay. Now my 0, 1 point is unaffected. That's still 0. But my other points, you'll notice that they just change signs. So I have a -1, -2, and then if room, -3. Okay? You don't have to multiply with the chart. If you can think about this conceptually, you're more than welcome to go ahead and graph it that way. So let's see. Okay, so instead of going right or left 1 up a half, I'm going to go right up a half. So that point is there. 0, 1. Let me go up 1. Back to my pseudo origin. The next one, I would normally go right 1 up 2, but instead of right, I'm going left. So left 1 up 2. Okay, same direction. Left 2 up 1, 2, 3, 4. And then I think I have room. I'll go left 3 up 8. 1, 2, 3, 4, 5, 6, 7, 8. So this is the same thing as our base 2 lesson, except I am having decaying values. These values are getting smaller and smaller and smaller rather than bigger and bigger and bigger. Okay, same exact values. So there is our function. There's our transformed function g of x. So here's g of x. Our domain, again, these are all the x values from negative infinity to infinity. That would be interval notation. And then inequality or set notation would be negative infinity less than x less than infinity. Range, these are the y values, where y is, in this case, greater than negative 2. And that would be negative 2 to positive infinity. Our y-intercept, this is one of our key points. We can see this here, 0, 2. And our horizontal asymptote is negative 2. End behavior. As x goes to negative infinity, our function g is approaching positive infinity. It's increasing rather largely on the left side. And then on the right-hand side, as x approaches positive infinity, our function is approaching the horizontal asymptote, which is negative 2. Okay, so there's our graph. There's the key features. I'm going to go ahead and give you guys a practice one, which is similar. So here you go. Please pause me. I would like you to graph this and then try to check out those key features. I'll show you the solutions here in a moment. All right, hopefully you went ahead and graphed this. The first thing that you need to do is rewrite this as base 2 with a negative c value. Okay, and that would look like this. So hopefully you got that. The horizontal asymptote is a positive 1 because that's your k value, positive 1. Now we're shifted left 4 up 1. So this is going to be your pseudo horizontal asymptote, which is left 4 up 1. And then you can see the points, right? So right 1 up a half, up 1, left 1 up 2, left 2 up 4, and then left 3 up 8, which may or may not be on your graph. The y-intercept, you may have had to work for that one. You may have had to plug in 0, so 1/2 to the power of 4 would be 1/16. So 0, 1, and 1/16. Our range was 1 to infinity, and then our end behavior was similar to the last example. X goes to negative infinity, g of x goes to infinity. X goes to positive infinity, g of x is approaching the horizontal asymptote at 1. Okay, so let's go ahead and look at another base 2 example, except this time I want to draw your attention to the c value and to the exponent of this function. Notice, compared to the last functions and our general form, that our value is not factored out. I'll show it to you right here. So notice how the c value needs to be factored out of the x minus h to really show your true h if you're going left or right. So looking at this example, I don't have that parentheses around the x and then the h value. So I need to go ahead and I need to pull out a negative. And when you factor out a negative, you're going to change the sign. So my x is now positive, and then so is this 3. Plus 3. Plus 5. Okay, so this is base 2. It's an exponential decay because it has a negative exponent, but it is base 2. So my a value, that's negative 1. The c value is -1. Our h value is -3. And then our k value is equal to 5. Okay, so I do have a horizontal asymptote at y equals 5, and then the pseudo origin is going to be -3, 5. Okay. Also, though, I do have reflection of two types. I do have a vertical reflection, and I do have horizontal reflection as well. So that's going to make setting up our axes going to be rather interesting. We're also shifted up 5. So I'm going to put my asymptote up here. I'm plotting that first. If that's 5, then this is 4, this is 3, this is 2, this is 1, and then this line right here will be our axis. So here's our x-axis. Here's x. Okay, and our y-axis, we're going left 3, so I'm going to place my y-axis over here. Here's y. Okay, so our pseudo origin, left 3, 1, 2, 3. So right here, there's our pseudo origin. Okay, now I'm going to plot the key points. I'll list them here again. So I have x, and I'll say 2 to the x. I have -1, 1/2, 0, 1, 1, 2, 2, 4, 3, 8. Okay, but remember, we're multiplying by a negative on the y values. This is our a value getting multiplied by -1. So all of these values are going to change. So down 1/2, down 1, down 2, down 4, right? Instead of going up, we go down. And then similarly with the x-axis, because of our c value, right? Our c value is also -1. I'm going to multiply all these values by -1. So instead of going left, I go right. Instead of going right, I go left. Okay? So I'll leave that for you if you want to compute those, but it's a basic concept here. So, okay, I'm at my pseudo origin. I'm going to plot my first point, left 1, up 1/2. Well, instead of going left, I go right, and instead of up, I go down. So right there's my first point. Instead of going up 1, I'm going to go down 1. Instead of right 1, up 2, I go left 1, down 2. Left 3, down 4. Left 1, 2, 3, down 8. Okay, and here is our exponential function. All right, there it is. Just set it to base 2, and I already know how to do that. Domain, -infinity to +infinity. So -infinity is less than x, less than infinity. -infinity to infinity. Range, these are our y values. So y such that y is less than 5 in this case. That would be -infinity to 5 in interval notation. Our y-intercept, that's not going to be an easy one. Let me go ahead and calculate g of 0. So we get -2 to the power of -3 plus 5. So this equals -1/2 to the power of 3 plus 5 equals -1/8 plus 5. So we get 4 7/8. So 0, 4 7/8. All right, just taking away 1/8 from 5. Horizontal asymptote again was 5. As x goes to -infinity, our function values are going to -infinity. And then as x goes to +infinity, our function is approaching 5, the horizontal asymptote. Okay, so you can see that there. All right, I have a practice problem for you of this type. Please pause me give this example a go. You can check back in a second. I'll go ahead and show you the factored out form for this example. So try this and check back in. All right, hopefully you factored out a negative in your exponent first. So that would be your function, okay? All right, go ahead, keep graphing. All right, here's the solution for this example. After factoring it out, again, our horizontal asymptote is at 0, y equals k, so y equals 0 is the horizontal asymptote. We're shifting right 4 units, so you'll see that here. And then we have a vertical and a horizontal reflection. So instead of going left, we go right. Instead of right, we go left. Instead of going up, everything is reflected down. So you can see these key points here. So right 1, down a half, down 1, left 1, down 2, down 4, down 8. And then here are the key features. Okay, the next idea that I'm going to go ahead and show you is base 1/10, which is an exponential decay function. I'm just taking 1/10 of a value, 1/10 of a value, 1/10 of a value. So similar to base 10, how things grew extremely fast. Here things are going to decay at a rapid rate. You can see the key points, and again, the key points that I want to highlight are when I plug in -1, you get 1/10 to the power of -1. Which is just 10 to the first, which is 10. If I plug in 0, anything to the 0 power is 1. And if I plug in 1, we get 1/10 to the power 1, which is 1/10, or 0.1. So here are the key points that we're going to go ahead and use when we graph this. And again, I hope you notice it's the same thing as base 10, just with a reflection. We're just reflecting it, okay? Here are the key features listed. Those should look familiar to you. You can pause me if you want to review them, but we'll talk about them here in a second. All right, here is the last example that I have for you. Please go ahead and write down this example. Now, what I'm going to do is I'm going to prep this to be base 10. So I'm going to change it to base 10 and use my negative exponent property. And there's my function. Okay, we have an a value, which is -1. That'll cause vertical reflection. C value is -1. That'll cause horizontal reflection. And then we have a k value, which is 3. So there's our horizontal asymptote. Y equals a +3. Our pseudo origin, where we're going to graph everything from, is just going to be 0, 3. We're not shifting left or right at all. But we do have vertical and horizontal reflection. Okay, so I'm going to place my x-axis rather high with enough room to go up for my horizontal asymptote. So here's x. Y-axis, I'll be fine right down the middle. Okay, and then our horizontal asymptote. So up 1, 2, 3. Okay, and that pseudo origin is right there, 0, 3. Okay, so I'm going to go ahead and graph my base 10 graph. Again, if you need those key points, there's only 3 of them. So -1 would be 1/10. 0 would be 1, and 1 would give you 10. But again, I have horizontal and vertical reflection. So instead of going left and up 1/10, I'm going to go right and down 1/10. Instead of just up 1, I'm going to go down 1. And instead of right 1, up 10, I'm going to go left 1, down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I do not have room for 100, right? That would be the next point. Left 2, 100. And I'm going to do my best here to graph this accurately. Okay, I'm going to approach that horizontal asymptote, and there we go. Add arrows to the end. Voila! There is base 10. Base 1/10, I should say. This is exponential decay. Okay. Domain, negative infinity to infinity. That's easy. The same thing every single time. Range, these are all of our y values such that y is less than 3 in this example. So that would be negative infinity to 3. The y-intercept, that was one of our key points. So we're at 0, 2. Horizontal asymptote, y is equal to 3. And our end behavior, as x approaches negative infinity, g of x approaches negative infinity. And then as x approaches positive infinity, our function is approaching the asymptote at 3. Okay, there you have it. Not too complicated. I do have a practice problem for you. Here is an example. Please go ahead, pause the video, try this example. Okay, here is the solution for the last example. Hopefully you rewrote it as base 10 with a c value of -1. We're shifting right 2 and down 2, so your horizontal asymptote y equals -2. And we just have base 10, so I'm going to go left 1, up 10, up 1, up 1/10. And then here are the key features. And your y-intercept of 0.98, you would find that by plugging in 0 into your function, and you would get 100 minus 2. And you could also visually see that too. If you went left 2, up 100, well, you're already down 2, so that would be at 98. Okay, before you go, just a couple of conceptual questions. Will an exponential function always have a y-intercept? Explain. Will an exponential function always have a 0? Explain. So the first example, our functions will always have a y-intercept because our function, the domain is from negative infinity to infinity. So I can always plug in a value of 0. Will an exponential function always have a 0? Sorry, it'll always have a y-intercept. Will it always have a 0? Well, that depends upon where our function is shifted, up or down. It may not have a 0. It might depend upon where we're shifted up and do we have a reflection. So always we'll have a y-intercept. Sometimes it will have a 0. Okay? Alright, that's going to do it for this video. Hopefully you learned how to graph exponential decay functions. Give me a thumbs up. Subscribe for more awesome math videos. I'll see you in the next one.